To maintain a perfect track, the line must be level both when there is no traffic on them and under traffic. The system of measured shovel packing provides a means whereby the amount that the length of line is out of level when under static conditions, and the amount that any particular sleeper is depressed by the passage of a train can be accurately and simply measured. From these measurements, the exact amount of chips which must be spread under each sleeper in order to get a perfect top on the line can easily be arrived at. The system can only be used where the ballast is suitable and not where the ballast consists of round gravel and sand. A gang for working measured shovel packing usually consists of a ganger, 2 men, and a lookout. On their arrival, the ganger first inspects the stretch of line and makes sure that all chairs are screwed tight to the sleepers and that the rail is tightly keyed to the chairs. Where chairs are not in close contact with the foot of the rail, the key is knocked out and re-driven while the sleeper is forced hard up to the rail. To measure how much the rail is out of level when no traffic is on it, a set of 3 sighting boards is used. The sight board, the intermediate board, which is adjustable for height, and the target board. The ganger sights along the rail and locates 2 high spots, 80 to 120 feet apart, and they are marked. The sight board will be clipped to the rail at one high spot, the target board at the other. The boards must be exactly level. A spirit level is built into each. They must also be firmly clipped to the rail after every movement. The ganger sits behind the sight board. The intermediate board is clipped 4 or 5 sleepers away. It should be lowered till its scale reads 0. The ganger, looking through the slot of the sight board, sees the intermediate and the target. The yellow and black squares on the target appear as narrow bands. The intermediate is adjusted till the ganger sees the bands disappear, and the intermediate's top edge coincides with the target's horizontal center line. The reading of the pointer against the scale is chalked on the rail below the intermediate board. This board is then moved 4 or 5 sleepers nearer the target, and the process is repeated again and again. There is now a figure at every 4th or 5th sleeper. These are graded by quarter, half, or whole canisters, and a figure given to each sleeper. Before the examination of the line under traffic, the ganger strikes the sleepers and finds out by the sound which of them are hanging. To measure the amount of hollow under a sleeper, an instrument known as a void meter is used. An iron stake is driven firmly into the ballast about 3 inches from the sleeper, and the void meter clamped to it. The turned down end of the spring-loaded pointer rests on the sleeper, close to but not touching the chair. Its other end should be some distance down the scale. The friction pointer is pushed down till its pin rests on the spring pointer. Twelve void meters are provided for a gang, and as many as possible should be set up before the passage of a train. train depresses the hanging sleeper. The spring pointer of the void meter goes up the scale, taking the friction pointer with it and leaving it at the highest point reached. After the passage of the train, the number of divisions between the two pointers is read, and this figure chalked on the sleeper. There is now a void meter figure on every hanging sleeper and a sighting board figure on the rail at each sleeper. These figures represent the number of canisters of chips which must be put under each sleeper. Before the other rail is similarly measured by sight boards and void meters, cross level should be taken on straight track to ensure that there is no cant. Where there are two figures applying to a sleeper, they are added together. The result is the number of canisters of chips which must go under that sleeper. The measuring canister for chips has a slot near the top. When 10-inch sleepers are being packed, the canister is filled with chips up to the slot. When 12-inch sleepers are being packed, the canister is filled to the brim. The boxing of heavy ballast between the sleepers is now opened out where the figures show that it is necessary. Where there is a continuous run, only alternate beds are opened. After this, the line is jacked up with the jack on the outside of the line for safety. Then the necessary number of canisters of chips is spread evenly under each sleeper for 15 inches on either side of the rail. It will be remembered that the figures read off from the sighting boards and the void meters represent units of canisters of chips. Each canister full, when spread under a sleeper for 15 inches on either side of the rail, is equal to 1/16 of an inch of slack. For this film, a newly packed sleeper was removed and revealed a perfect bed of chips for 15 inches on either side of the rail. All that remains to be done after every sleeper has been packed is to backfill the boxing. A test taken with a void meter while a train passed over a newly packed sleeper revealed no slack at all. On curves, sighting boards are used on the low rail. Then the high rail must be adjusted to the static measurements on the low rail. The step board for checking cant is graded in steps of 1/8 of an inch. For too little cant, add twice the number of steps to the number of canisters of chips to go under the high rail sleepers. For too much cant, deduct twice the number of steps from the canister figure. If the excess of cant figure is greater than the figure on the low rail, the high rail must be lowered by the difference. If, however, excess cant persists all along the curve, the differences may be added throughout the low rail. After finding can figures for the high rail, void meters must be used on hanging sleepers. Measured packing has undergone extensive tests of the LMS and is being generally adopted. Attention to the details of the process will give a packing as nearly perfect as it can be.